Welcome. In this lesson, we will see how to convert the image color using OpenCV, that is converting it to gray color and changing the different color formats like BGR, RGB, etc. So let's load the image. The img equal to cv2.mread, and we will use the same image which we have used in the previous lesson, that is in the images folder, and the name of the image is flamingo.jpg. Alright, so let's execute this, and now print img. As I said, what are the values that is being displayed here is pixels. So each and every value represents the pixel. Since this is the color image, that is particularly it will read the image in BGR format, so this whole represents 1 pixel. So this is the first one is B, and second column is G, and third column is R. So this basically represents the intensity of the particular color, and if you mix all together we will get 1 pixel. And also one more important thing that you need to understand is that all the images that we are going to be studying is all are unsigned 8-bit integer. So all are unsigned 8-bit integer, so that's the reason the range of pixel values is between 0 to 255. For an n-bit image, the range of pixel value is 0 to 2 to the power of n minus 1. That's the reason for an 8-bit image, the range of pixel values is between 0 to 255. As I said earlier, 0 represents darker and 255 represent lighter in color. Okay, so now what we will do is that let's try to understand what this image is. So what this matrix is basically represents. So for that, let's look into the shape of the matrix, and we have 3 channels are there: red channel, green channel, and blue channel. So each and every channel is basically represents the color. So what we can do here is that in order to understand better, we will split the matrix into 3 parts. Remember that OpenCV reads an image in BGR format, so which is equal to img dot, we have a in CV2, which is equal to, in CV2 we have a module called split, and use that module split and split the image. What we want to try to do is that it will try to split the image here. img, we have successfully split the matrix into BGR. B stands for blue matrix, so this matrix is basically represents the blue color. Lighter that is darker blue, and or almost nearly equal to the black, and 255 is the pure blue color, and in between we have the mix of blue color is there. Okay, so we can also display that. So in order to display, we can use a cv2.mshow and provide the window name to blue, and the matrix is B. And after that, let's cue the wait key here of 0, and immediately after wait key I just want to destroy all windows, and let me display even my original image. plt.mshow, this is what my color image, and that's my img. Execute it. So this is what my color image, and this is what my blue image. What do you understand from this is that as I said, darker is non-blue and the lighter is the blue. You can see here there is some kind of gray mix is there, so this indicates some kind of blue color. That's why we have some grayish color here, and of course there is some white color is there, mix of white color is there. Of course white will get anyway white here. Okay, so this is about this. So let's look into our red color. Probably my image is more or less red, and probably I can get this. For this I might get highlighted here. Let's see my red color. So for that, plt.mshow, let's display the red comma R. also display the green color. So command G. Okay, now I displayed all the images. So this is, I guess, the red color. You can see this is the red, and as I said, like, you know, obviously this image indicates, like, you know, that lighter is more closest to the red, because this is the red matrix, and the darker is not closest to the red. And here you can see that, like, you know, this is more closest to the red. That's why we got, like, you know, something like this. This is really cool, right? And similarly, let's look into our green color. Obviously there is no green mix, is not there, but what we can say here is that it will only show you where exactly your white color, where exactly in the color it will only displays the where exactly white, and rest all it's not that much lighter. So this is how, like, you know, we can understand the image. We can split the image into 3 different parts, and you can analyze each and every part individually. Red consists of information about the red color, green consists of information about the green color, and blue consists of information about the blue color. You can also try with the different images so that you can understand much more effectively. What I'll do is that, like, you know, let me convert the color here. Since this is what my BGR image, what I can do is that I can convert that into RGB image. Let's look into that. Color converter. So in order to convert that color, what we can do is that, like, you know, we have a module in CV2 which is CVT color. Let's use that. CV2.CVT color, and use this module CV2 color. And there are 2 arguments you need to keep in mind, is that one is SRC is an input image array, and code is what kind of conversion you want, what kind of color conversion you want. For example, in my case, my image is IMG, and the color code when I just want to provide is just provide CV2 dot and use the capital letters color underscore, and if you press keyboard shortcut tab, it will display all the color code conversions. So let me see, this is my color is BGR, the current color is BGR, and you can see there are a lot of color codes are there which we can able to convert. What are the color you want, you can convert that. In my case, I just want to convert the color into BGR to RGB. So what I can do is that I can simply select that, so BGR2, and you can see RGB is there. This is BGR2 RGB, select it. So this is what my image underscore RGB. That's it. What we can do here is that we can simply convert that image into RGB image. This is really cool. And even you can also convert that color into the grayscale. And for that I can do the variable gray equal to cv2 dot convert color, and what is the name of the image I want to convert is this, and provide the color code. It is color underscore BGR2. There is gray is there, you can select the gray. What it basically does is that, like, you know, it will convert that BGR format to the grayscale image. So let us display all the 3 images. One is cv2 dot imshow. The first color is, this is color BGR. Just remember, like, you know, by default this will read an image in BGR format, and also the display format of the OpenCV is BGR only. So let me use this IMG, this is the BGR, and cv2.mshow, and color, this is an RGB, and that's IMG underscore RGB. And similarly, let me also show the grayscale color, and let's put the wait key. And destroy all windows. Let's execute it. Perfect. So we have, this is my BGR, this is the perfect color, and RGB is basically the inversion of this. This is the invert color. So basically it's trying to invert it, because like blue is replaced by red and red is replaced by blue. You can see that blue is replaced by red and red is replaced by blue, and white is white and green is obviously the green color. So that's why you have like some different combination of color is something like this, is because like this we just change the color here. And similarly the grayscale image, this is my grayscale image. Perfect, right? This is how we can convert the colors from BGR to RGB, BGR to gray. Like this you can convert what are the color code you really want, you can also really convert that. So let me save that. Finally we are ready with that. So let me save my grayscale image. I can do that. cv2.mwrite, and we can save that. Let's say this is what my gray.png, and the name of the image is gray. Let me execute this. Done. Now you can see here we have our grayscale image is there. This is what I just converted the grayscale image. Perfect, right? Excellent. This is how like we can do the color code conversions in OpenCV. I will see you in the next lecture on accessing and image manipulations in OpenCV. Guys, welcome back. I know the previous lectures are not super exciting. What we did is just simply load an image, display the image, and save it in some different file format. Now what we will do some exciting stuff in this lecture, that is accessing and manipulating the pixels. So first what we need to do is that we need to do import necessary libraries like CV2 and numerical Python. Once we did, then we load the image. This time we load different image. So we can load an image pv2.mread, and I just want to load an image from the images folder, and this time we'll go for bird.jpg image. Let's execute this. Now let's look into the image by using some function mshow and wait key and destroy all windows. Every time writing all the commands is not recommendable. Instead what we will do, we will create some simple function and we will call that function. Now let's define a function, def display, and the function that I'm going to display and the two arguments I'm going to provide here. One is WinName and the second one is image. Now so let's display it by cv2.mshow, and the first one I need to provide is WinName and second one is image array. Then we'll do the wait key. I will provide the 0, and after that destroy all windows. Okay, execute it. Now let us use this function and display the image what we have read. So display, what you need to provide is the window name is WinName, and I'll just give this is my image. Perfect. So this is what the image that I'm going to be work on now. Excellent, right? Now what I'm going to do in this example is just trying to accessing some pixels. So let's look at the shape of an image first. My image shape is, we can find out by img.shape, and by executing this command we can get like what is the shape of an image. And the shape of an image is 681 rows and 640 columns. That means we have 681 rows and 40 columns are there in this image. So what we'll do is that let's try to access first 100 rows and first 100 columns. We know that image is simple numerical Python array. Just like the numerical Python, we can also access the arrays, or we can also slice the array using some slicing method in numerical Python. So what we will do exactly the same thing like slicing method. So let's use a slicing. because it's a numerical Python. You can look at the data type of this is IMG. It is a numerical Python. Basically, it is a NumPy array. So now what we will do, let us try to access first 100 rows and 100 columns. Just like the numerical Python, you can do that. Let's say I'll name it as corners, and that's going to be equal to IMG, and just use the indexing. What we need to do is that, like, first you need to provide the index rows, so 0 to 100, and also I'll just provide the columns I want from 0 to 100. Execute it. So that's it. So now what we got is that, like, we got the corners where we accessed first 100 rows and first 100 columns from the image. Let us display it using display function of corners. You can get that. Oh, and you just need to provide the window name here. So let me provide the name corner. Exactly. So this is what the corner, you can see I'm accessing the first 100 rows and first 100 columns. So what I'll do here is that, let me also display my corner, as also I will display my image. So for that, I'm show, this is what my original image, and this is what my IMG, and similarly pcv2.mshow. Let me also show my corner, and that's my corners, and let me use a wait key of 0, cv2.destroy all windows. Execute it, and as you can see, this is what my original image, and I can able to access the first 100 rows and first 100 columns. Just like, very simple. It's almost similar to your NumPy indexing concept. Cool, right? So now what we will do, we understand, like, how to access the pixels of an image, and we can also do the manipulate those pixels. What are the pixels you have considered? We can also manipulate those pixels. So what I'll do in my case is that, like, since I access the first 100 rows and first 100 columns from the image, and I just want to change that into some green color. Let's see that how to do that. So changing color, changing first 100 rows and 100 columns to green color. Let's see that. So it's very simple. The first what we will do is that, let's define the green color with variable green, and just define the green pixel. The green pixel is 0, 255, 0. For 8-bit array, it is 0, 255, 0. That's it. It's very simple. That's my green color. Now what I can do here is that, let me change the color, and we can simply change the color using access. First we'll access it, so 0 to 100 and 0 to 100, and assign for this, assign green. That's it. So this is how we can manipulate the pixels, means you can change the pixels. Let us display my image now. Display IMG. So first one is, this is my manipulate. That's my IMG. Let's execute this. Perfect. Now we can see that. So we have, this is the green color. This is my first 100 rows and first 100 column. I accessed it, and I changed that into the green color. Perfect, right? This is how we can do, and we can access, and we can manipulate the pixels using OpenCV. You can now play with this by applying to the different images with the different colors and different positions. I will see you in the next lecture how to draw the drawings using OpenCV.